Hi, 7th graders. We're on Lesson 5, Session 2 in your book, which starts on page 87. And today we are solving multi-step ratio problems. So we're going to be looking at multiple ratios. Our try it problem says Francisca and Elizabeth are participating in a walkathon. Each girl walks for 3 hours. How much money are they going to raise together, specifically? And it tells us over in our graphic over here that Francisca is raising $25.50 for every half hour. And Elizabeth is raising $14.50 for every quarter hour, so every 15 minutes. And so what we're going to do here is we are going to figure out how much they're each raising per hour. Then we're going to find out how much they're raising for every 3 hours. And remember, the per hour is their unit rate, aka their constant of proportionality. So if, let's get my blue out, if Francisca, I cannot say that name, Francisca is raising $25.50 every half hour. You can math that out. You can do 25.5 divided by 1/2. But it's half an hour, so we just need another half an hour, so we just need to multiply it by 2. So 25.5 times 2 is, see, 25 times 5 is 50. Double half is a 1, so this is 51. So Francisca is doing $51 per hour. That's her constant of proportionality. That's her unit rate, $51 per hour. Elizabeth is doing $14.50 per quarter hour. And again, you can fully write out 14.5 divided by 1/4. But you know that to get a full hour, you need to multiply 1/4 times 4. 14.50 times 4, I can magically do that in my head. That's $58 per hour. Okay, fine, I didn't do it in my head. I looked at the teacher's guide. Whatever. Okay, so Elizabeth's constant of proportionality is 58. Her unit rate is $58 per hour. But we want to know how much per 3 hours. So I'm just going to multiply times 3. That's going to be 3 times 1 is 3. 3 times 5 is 15. So Francisca is raising $153. And again, we want to know for 3 hours. 3 times 8 is 24. Carry the 2. 3 times 5 is 15. 16, 17, 174. So Elizabeth is raising $174, but we want to know how much together. So 153 plus 174 will give us $327 in total. Alright, so that's how much they're going to raise. Now, let's see how the book wants us to do it. The book wants us to do this. Ooh, this is the same thing we did, isn't it? So Francisca raised $25 every half hour, so that's $51 per hour. Elizabeth raised $14.50 per every quarter hour, so that's $58 per hour. And then they just, mathed it out. However, if you recall from previous lessons, we also have the option to write it out with the formula y equals the constant of proportionality. So in this case, in Francisca's case, it's 51. The constant of proportionality times x. They've changed it. Instead of using x and y, they're using m for minutes. No, for miles or money, and h for hours. So all they really did here was constant proportionality times the hours, and they plugged the hours in. So you can use an equation for it as well. For number 1, so look at the first model. How can you identify the constant of proportionality from a verbal description? Well, the verbal description is what? Francisco raises $25 every 0.5 hours. So what you would do is, I'll type this one up. Find the two, I'm gonna make this bigger for you, hang on. There you go. Find the two quantities, aka the two numbers, the two amounts that have a proportional relationship and divide them. That will give you the constant of proportionality, aka the unit rate. There you go. Look at the second modelet, where we use an equation. And where is the constant of proportionality in each equation? How can you use it to find how much money the girls raised in 3 hours? Let's see, the constant of proportionality was, the constant of proportionality was the coefficient. I'm going to make you memorize that word. Remember, the coefficient is the number that is attached, that is touching the variable, the letter. The constant proportionality was the coefficient for the h variable. You can substitute 3 for h. To find out how much each girl raises in 3 hours. How much each girl raises in 3 hours. There we go. Number 3. How much money do Francisca and Elizabeth raise together? You could use the equation M equals 51 plus 58 to find the amount of money they raise together. Why? So together they raise, what did we say? $327. And you can use this equation where instead of doing 2 separate equations and then adding the answers, you can add the constants of proportionality first and then do the equation. And why does that work? Let's see. That works because the h will be the same. So both would be multiplied by 3 anyway. That's not what the teacher's edition says. I'll read you what the teacher's edition says. It says, one way to solve the problem is to find the amount of money each girl raises alone and then add the amounts together. Another way is to find out how much the girls will raise per hour together and then multiply by the number of hours. So that works too. Number 4, you have identified the constant of proportionality in tables, verbal descriptions, graphs, and equations. Why is this helpful when solving problems that involve proportional relationships? Well, if you know the constant of proportionality, you can find pretty much any answer, right? But specifically in tables, verbal description, graphs, and equations, we will say being able to identify the constant of proportionality in many representations, many different ways, lets you use the form that's most helpful to solve any given problem. So sometimes you'll have a table, sometimes you'll have a graph, sometimes you'll have a sentence, and it might be easier to do it different ways. Okay, number 5 is for you to do. Think of all the things we went over. Pick the one thing that was most helpful to help you understand the lesson. Write it down. Pause, do that, and then come back and we'll practice. Okay, so you've written that down. We've got 3 practice problems here. Number 6. At a certain bookstore, you get a $5 coupon for every 4 books you buy. $5 coupon for every 4 books. What is the least number of books you could buy to get $15 in coupons? Show your work. Okay, well, we need to build a constant of proportionality here, and we know that the quantities that have a proportional relationship are these two quantities here. So we will write 4 books per $5 in coupons, because we want to know how many books per coupon. In the end, we want to know how many books per 15 coupons, $15 in coupons. And let's see, we want the known quantity that we will know is coupons. And what we want to find out is how many books. So that's the unknown quantity. We're going to put that on that side. Now it's asking you how many books for $15 a coupon. So it gives you the amount of coupons. So I can take that out and replace it with how many coupons. I'm going to put parentheses around that to keep it tidy. But remember, when two numbers are touching through parentheses, that just means multiply. So we're going to multiply 15 by 4/5. So 4/5 times 15. Put a 1 under that 15 if that helps you. Not really necessary, but you can. And then we just, okay, we're going to back up here. You can just multiply across. You can do 4 times 15 is 60. 5 times 1 is 5. You can do that. That's totally fine. I'm going to back up here for a second. I'm going to cross reduce, which you may do if you like. So only when you are multiplying fractions can you reduce across before you actually solve the problem. So I can't reduce 4 and 1, but I can reduce 5 and 15. I can reduce those both by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So now, instead of doing 4 times 15, I'm just doing 4 times 3, which is 12. And 1 times 1, which is 1. Which is the same, by the way, as 60 over 5. Those are the same thing. But I just did it a different way. Either way works. So now we've got 12 books. We'll give you the $15 in coupons. 12 books. If you solve that another way, that's fine. But practice at least finding the constant of proportionality. Number 7, swim team members can race or dive. At a meet, 18 members choose to race. The ratio of racers to divers is 6:2. So we've got 18 racers, and the ratio of racers to divers is 6:2. So remember, the order that you state things matters. How many members are on the team? Show your work. Okay. So we have 6 racers to 2 divers is going to be 8, but we have 18 racers, and we need to know now how many divers, and then we need to add it all together. Okay, let's see. Well, you can probably figure out just by looking at it that 6 times what is 18? Times 3. So that means you need to multiply by 3 down here as well. So this is going to be 2 times 3 is 6. And so there's 18 choose to race, 16 choose to dive, 18 plus 6 is 24 team members. Okay. Number 8. Roberto runs 25 miles. His average speed is 7.4 miles per hour. That's his unit rate. 7.4 miles per hour. The per hour means it's the unit rate. He takes a break after 13.9 miles. How many more hours does he run? Show your work. Okay, Roberto runs 25 miles. His average speed is 7.4 miles an hour, so he's going at a constant speed and it says per hour, so we know this is the unit rate, 7.4 miles per hour. That's the constant of proportionality. That's the unit rate because it says per 1 single hour. He takes a break at 13.9 miles. So he's taking a break there, and it's asking us how many more hours does he have to run after? We can easily figure out how many more miles he has to run, but what does that translate to in hours? So we could set it up like this. He's going, oops, not highlighter, ooh. He ran 25 miles total, but he already did 13.9, and we didn't know how many miles are left. And then to translate it into hours, it's 7.4 miles per hour, and we don't know how many hours. That's what we're trying to find out. So 25 minus 13.9, I'll do that work over here. 25 times 13.9. Now there's this empty space up here. I'm just going to fill it in with a 0.0 because that helps me keep things lined up. And then once the decimals are lined up for subtracting decimals, you can just pretend it's not even there. This is just 250 minus 13.9 in my head. So I'm going to regroup here. 10 minus 9 is 1, 4 minus 3 is 1, 2 minus 1 is 1. So he has remaining 11.1 miles to go, and we didn't know how many hours that'll take him at a rate of 7.4 miles per hour. And you may or may not remember from 6th grade that when we have a coefficient and a variable and we want to get rid of that coefficient, we are going to divide by that coefficient, because this is 7.4 times h. We need to do the opposite to get rid of it. 7.4 divided by 7.4 is just 1h left. I have 1h remaining. But the number one rule with solving equations is whatever you do to one side, you must do the same thing to the other. So 11.1 divided by 7.4, that is going to give us 1.5. Roberto will run for 1.5, ran out of space, hours more. Okie dokie. Here are your green pages, and good luck.